Good afternoon. This is Group 8, Kristen Parkinson and Joseph Hughes. We are focusing on Chapter 16, Enable Feedback so Development and Operation can safely deploy. In this chapter, we learn the reasons why feedback is so important, and we get a little background detail on the fear of pushing code into production and why this information is necessary to help us understand how DevOps can safely deploy code without the fear of breaking production. The introduction gives us a glimpse as to the worry about pushing individual code into production. There's a fear that can paralyze or slow down the business impact of the value stream. We're also given the example of how ideally code can be deployed, giving confidence to developers and ensuring that knowledge is learned and shared. To overcome this fear of pushing code, we must also migrate the monitoring of production telemetry into our development work, as well as establishing a cultural norm that everyone is equally responsible for the health of the entire value stream. We create feedback mechanisms that enable us to improve the health of the value stream at every stage of the service lifecycle, from production design through development and deployment into operations and eventually retirement. Now we do this by using telemetry, an automated communication process by which measurements and other data are collected at remote or inaccessible points that transmitted to receive equipment for monitoring. Actively monitoring telemetry can give us almost immediate feedback on whether production deployments is operating as it was designed. Code should never be considered done until it is operating as it was designed. Not only does telemetry tell us if the code is working, but it can also indicate whether the code has inadvertently affected another portion of production. To fix these problems, we have the three options. We have toggle, which is the no risk option, choosing to turn off and on broken features. We have the fix forward, which makes changes within production. This is a little bit more scary to some developers. And then we have the rollback, which is just switching everything back to the previous release by using features or toggles that take in everything broken out of the system. And we can use the blue-green or the canary release patterns. One big problem in operations is burnout. Being constantly on call to fix alerts at 2 a.m. can cause chaos and disruptions. To prevent this, every member of the value stream has shared responsibility of handling operation incidents, and everyone shares the pager rotation, not just the dreaded development checking the code over the wall for the operations to manage. Patrick Lightbody, an SVP of product management at New Relic, states he found that when he woke up developers at 2 a.m., defects were fixed faster than ever. All members of the value stream make an effort to make sure features are done in production, thus giving dev an additional layer of feedback as to how their code is running in production. We have developers follow work downstream. By allowing them to do this, they can see how customers use their product. One effective way is to allow dev to see how their features affect the end users. This section gives us an example of Gene Kim, founder and CTO of Tripwire, who said that one of the most worst moments in his career was watching customers use their product. It was clumsy, monotonous, and required dozens of clicks to perform operations on a weekly basis. The exercise gave him empathy and a greater desire to help everyone in the value stream, not just the end customer, and helped create a better DevOps work culture. Have developers initially self-manage their production service. Even when dev pushes their own code, they may not fully see and understand how it works in production and downstream. Google provides a countermeasure to these oversights, and it has dev detect accounts and severity. It does the application actually perform as it was designed. They have a type frequency of pager alerts, and their questioning is the application generating unsupportable number of alerts in production? They have monitoring coverage, and their question is the coverage of monitoring sufficient to restore more service when things go wrong? This continues, and we have system architecture, is when the service is loosely coupled enough to support the high rate of changes in development and production. The deployment process is there a predictable, deterministic, and sufficiently automated process to deploy code into production, and production hygiene. This is where evidence of enough good production habits that would allow production support to be managed by someone else. Now, if there are deficiencies, if deficiencies are found during the review, additional questions need to be asked. Upon answering them, we can determine if operations should be embedded with dev at the start of the project and or whether the service should be handed back to development. Additional questions may need to be asked, like whether the service generates revenue or is a significant amount. Does it have higher traffic or a higher cost amount during an outage? Does the production store information that could be considered personal, private, or apply to regulations? And more specifically, are there regulation compliance issues that need to be followed? Once these questions are answered, we can determine if integrating operations engineer into the development process would make the process run better. We could also work out service handback mechanisms, which determines if service should be handed back to development if it's highly volatile and incurs a large amount of technical debt to solve the issue. The case study is the launch and handoff readiness review at Google. The case study shows us that handback remains a long-standing practice at Google and demonstrates mutual respect between operations and development. Google has developed two critical stages of releasing new services. They have the launch readiness review, which is the LRR, performing and signed off before any new Google service is made publicly available, and the handoff readiness review, which is the HRR, performed when the service is transitioned into an ops managed state, usually after an extensive LRR. Each of these has an SRE or a site reliable engineer assigned to them to help them with the transition and understand the requirements. Usually, the fastest approvals occur when the SRE is involved from the beginning. This practice helps all involved to be good and fair company citizens and in helping each other succeed. In conclusion, we can overcome the fear of development code by following the suggestions outlined in this chapter. Have dev work with ops for calls and fixing problems. Have dev see how their products work with customers. Have dev manage the product at first and create a service handbook mechanism to determine when handoffs really should occur. Lessons we've shown here have been shown effective at Google. So let us know if you have any questions. Thanks.